Hello, Twinkle Twinkle students from Magnolia. Today we're going to explain space-time. Now you humans think you know space-time, but I'm trying to tell you, you're not thinking as a space-time. You're thinking all in just distance. So here is a point that I show right here with my little pencil tip. See it? That's what we say time zero. Time's going this way. We can call this 1 second. Run, 2, 3, and so forth. These are time going on. Okay, but you're right here at the very start of time, and you have a ball in your hand, a ball. Now, what humans think, what they think is happening, and it's not really happening, is that when you throw the ball upwards, straight up, look, the green is the ball going up, and then when gravity overcomes the velocity of the object being thrown on the air, it comes back down. That you know. But a ball does not travel like that in space-time. Because why? Because when you're right here and you throw the ball up, you see this first green spot right here, this first green ball? What you have to realize, as soon as the ball left your hand, you got older. The ball is going up, but time is also moving this way. See it? So when you first follow the ball up to here, this much time has gone on. And so we graph that position not on the y-axis, but here on a combination of the y, which is the y is the height of the ball going up, and t is time as you get older. So when the ball reaches here up to this point, you see, you're even older. So now 2 seconds have gone by. When the ball reaches up this high, even 3 seconds have gone by until you hit the top, and that's when the gravity starts pulling back down. So now the ball's coming down. Just think how old you are now from when you first threw the ball into the air. Then it goes this way, see? And now the ball's coming down, so time's gone, even more time's gone. Look at the red ball here. Even more time's gone, and even more times. So the nice thing about physics is any object that you throw that has a gravitational field pulling on it will always fall in this shape. And what do we call that shape? That's the famous parabola. So all objects in a gravitational field in space, when I talk about space, I'm talking about the distance that is covering. That's a distance. Space is equal to height. But where it tracks, now you have to remember, every time the ball's going up and coming down, you're getting a little bit older until over here is where it actually hits the ground. And this is why in algebra, you give you a parabola and you want to find these x-intercepts. Because in physics, that's like the time you throw something up the air, and this other x-intercept would be the time that it comes to the ground. And that's it.